Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today, I would like to discuss about the most suitable manufacturing processes and technology used to fabricate the paper clips for subject MEM 360. Before I start my presentation, I would like to introduce my teammates. First of all, my name is Afdal bin Baharin and I will be the first presenter. The next presenter will be Muhammad Daniel Hakim bin Muhammad Noor, and the last presenter will be Muhammad Shazmil Izzat bin Muhammad Suhaimi. Our lecturer name is Sir Abdul Aziz bin Muhammad Yusuf. Paper clips are mostly made from galvanized steel wire. Galvanized steel wire is considered an all-weather material which makes it so popular among builders. Galvanized steel wire is often used in constructing large office buildings because of its unmatched strength. Galvanized steel is steel that has been dipped in a zinc coating, which gives it good corrosion-resistant qualities. But galvanized cable will rust and corrode if salty, wet conditions are present. Galvanized coating perform well under extreme cold and hot temperatures. In long term, continuous exposure, the recommended maximum temperatures is 329 Fahrenheit or 200 degrees Celsius. Continuous exposure to temperatures above this can cause the outer freezing layer to peel from the underlying zinc iron layer. The gem clip is often held up as a paragon of modern design. It is simple, elegant, and surpassingly functional. Yet, leaving the iconic shape aside, a paperclip designer must consider a host of mechanical and engineering questions. The material used to make a paperclip must possess certain properties. The wire needs to be stiff enough to hold each shape in use, but not so stiff that it is difficult to open. Engineers also consider a quality called yield stress when designing a paperclip. Yield stress is the amount of stresses needed to permanently reshape the wire. If the wire has too low yield stress, it will stay bent open and not hold the papers tightly. Engineers also must consider the cost effectiveness of the material used. Using a cheaper, thinner wire may save the manufacturer money. Yet the material must also perform well in the manufacturing processes, not leaving sharp bursts at the cut ends and resisting cracking or breaking. The finished appearance of the clip is also a design consideration. The clip can have various finishes, smooth and slightly serrated, shiny or dull, and it can be made in many different sizes. The manufacturing process for paper clips is fairly simple, using a specialized wire forming machine. Moreover, the process has not changed much since the 1930s. The process begins with a huge spool of galvanized steel wire. A worker feeds the end of the wire into the paperclip machine. A finished paperclip has 3 bands. The machine forms the wire into these 3 bands by cutting it and passing it by 3 small wheels. The wheels are slightly roughened and catch the length of wire as it passes. Next, the first wheel turns the wire 180 degrees, making the first bend. The second makes the next bend, and the third wheel makes the final turn. The entire process is so quick. The machine can churn out hundreds of clips a minute. Lastly, the finished paper clip fall into open boxes. The boxes are shut and sealed, depending on the size of the factory. Many paperclips machines may be operating at once. Automated controls allow one worker to monitor dozens of machines. This is the simple illustration of the paperclips.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Hakim. So next we go to the advantage and disadvantage of the process from manufacturing of paperclip. there are many type materials that can be made to use to make the paperclip, such as plastic, galvanized steel, and others. But for the common paperclip that be used to make the paperclip is galvanized steel. So the we go to the advantage of using galvanized steel. First of all is lowest first cost. Galvanized steel is lower in first cost than many other commonly specified protective coating for steel. Second, the galvanized steel is less maintenance. Even in case where the initial cost of galvanized is higher than alternative coating, galvanized is almost invariably cheapest in the long term, so that we can lessen the maintenance for the galvanized steel. Third is faster erection time. As galvanized steel members are received that are ready for use, no time is lost on site in surface preparation, painting, and inspection. When assembly of the structure is complete, it's immediately ready for use for the next construction stage. Last, toughest coating. A galvanized coating has a unique metallurgical structure which gives outstanding resistance to mechanical damage in transport, erection, and service. So we go to uh, the disadvantage of using galvanized steel. First, it can be high cost when galvanized steel is large scale project. This may not make it feasible for some project where budget is a large determining factor. Second, although resistant to red rust, galvanized steel can develop white rust over time if exposed to moisture. We go to the the advantage and disadvantage of bending process. First advantage of bending process is high accuracy of bending. The bending speed of the pure electric bending machine can be adjusted. It can bend to different thickness, different material, and different bending length. Therefore, it set more appropriate bending speed and improve the bending precision and maintain high productivity. Second is product efficiency is high. When we use the bending machine, we can faster the product making in so the rate up of the product efficiency will be high. Lastly, energy saving, because we don't need to use the people energy to make the bending process when make the paperclip. Next is disadvantage of bending process is variation in thickness. This because when the bending machine is can not adjust the thickness of the paperclip. Next is require large bending force. For making a bending for paperclip, it will require the large bending force to make it bend. Lastly, we go to the advantage and disadvantage of cutting process. The first advantage of cutting process is increased accuracy of the cutting. Most of the metals that undergo machining are used in manufacturing industry. These include plates that require manual turning and milling process. Second, increase efficiency. Machining is one of those best ways that can help increase efficiency on your metal. When machining the metal, they are always fitted with internal quality assurance detector that bring along lot of efficiency in terms of increasing speed of production of the metal and ensuring good usage of raw material. Third is identical product. The finished product such as cutting metals are homogeneous and have very little or no error despite the high rate of production. As a result, the product become marketable due to their improved quality. So we go to the advantage of cutting process. First, higher force required. That we need use higher force to cutting the material when using the cutting tool. Second, cutting is not clean. When using a cutting tool, we cannot make sure that the cutting process is clean because of the process when you use of cutting tool. When the cutting is not clean, we can occur the accident for the other workers. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Shazmil Izzat bin Muhammad Soimi. I'm from J4 AM104D. My ID number 2019442852. So my part is about three possible defects that could happen during fabrication of paper clips. So the three possible defects, the first of all is the surface quality defects. Example of the surface quality defect is surface cracks. Surface cracks refers to the steel surface cracking phenomenon. Generally should be consistent with the direction of fogging and rolling. Reason: the hairline cracks, hot cracks, and cool cracks is mainly caused by excessive surface burn, decarburization, loosening, deformation, and excessive internal stress in the processing, fogging, rolling, heat treatment, and tempering, and too much surface impurities such as sulfur and phosphorus. Surface cracks can be detected by visual inspection, pickling, magnetic particle inspection, penetration test, and metallographic test. When confirming the cracks, it must be noted that the outside skin on the steel surface itself is brittle and loose. And the other one is the cracks appearing after the slight bending and the steel itself is not cracked. So the second defect is inclusion. Example of the defects is shrinkage hole. In the specimen with low magnification, the shrinkage hole is located in the center, and the surrounding is often the place where segregation, inclusion, and looseness aggregate. Sometimes, the cave or gap can be seen before correction. After the correction, the hole partially darken and show irregular folds. Reason why the shrinkage hole happen: during pouring, if the final solidified pipe is not filled after the molten steel solidified and shrunk, a microscopic hole will be left. The shrinkage hole is mainly formed at the head of the steel ingot. And the third one is size defect. The example of such defect is bending effect. bending defect. Generally, the defects and belonging to human handling bending after shearing or blanking, the material often has fine cracks on the edges. When bending, it tends to form stress, contraction, and broken. The following figure shows that the workpiece is fractured. When the workpiece is fractured, this will make the cracking position occurs in the shearing of the workpiece. So that's all from me. Thank you.